Hello everyone, this is Ari from Pantech. So in the previous session, we have developed the code for measuring the frequency, and today we are going to get into the concept of floating point unit. Okay, and we will interface the ultrasonic sensor and we will measure the distance. Okay, first we will see what is floating point unit, and we will get into the code development for ultrasonic sensor. Okay, so what is this floating point unit? So what is this is used for? So it is simply for the mathematical calculations. So we will use the lots of floating point numbers, right? So when I'm measuring the temperature value, I have to see the values apart from the point also. So point values, floating point values. So we have to see the floating point value also. So we will measure the floating point value also. So for that purpose only, we will go to the floating point concept. So what is floating point unit is when we use the software to do the mathematical calculation using the floating point means it will take time. So comparatively, what is this? This is floating point unit is a hardware unit which will be independently present inside the Cortex M4 IC. So what it is going to do is instead of software performing the floating point calculations, it is going to send this values to the hardware, which is there will be a default hardware, independent hardware, which will be inside the Cortex M. It will send floating point values to the floating point unit. So this hardware will do the calculation. So what is the benefit is it will do the calculation in a very much faster way comparatively doing the floating point calculation using the software. Okay. So it is like when you take a development board means you want to hardware for communication. But I2C SPI all comes under the software side. Like that, the floating point unit also we can use this floating point in both the ways. We can use it in a software way and we can use it in hardware way. So in our ARM Cortex M4 family, in ARM Cortex M4 IC, we have a dedicated floating point unit, which is a separate hardware. Wait, I will show that. So you can see. So in M0 and M1, we have a basic data processing in input-output control stars. When it comes to the M3, it will have an advanced data processing with field manipulation. When you come with what is the controller we are using is M4. So when you compare these both the controllers M4 and MF means we have a floating point unit as well as a digital processing unit. Okay. So we will get into this. So you can see we have this is the block diagram inside the IC. So which is the ARM Cortex M IC. So inside this you can see we have an AVIC which is a separate interrupt controller. Then we have, you can see here we have a floating point unit as optional. We can use this or we can use this software or we can don't want to use it means we don't want to use it. So if I want to use it, I want to do the calculation in a very faster way. In a minute faster way means I will use this configure this floating point unit which is a separate hardware. Then the values will be sent to this floating point unit and it will do some process mathematical calculation using the floating point will be much faster way comparatively doing with the software. Okay. So we have a floating point. We can use this floating point unit in two ways. One is single precision and another one is double precision. So when come with single precision, we will have these 23 bits as a fractional and 8 bits as an exponent, and we have 1 bit as an. Then when it comes to the double precision means we will have an exponent as an 11 bit and fraction as an 52 bits. So but the Cortex M4 as an FPU of only supports a single precision. Okay. So this is a basic example for the floating point calculation. Okay. So we are going to this formula. This code is for deriving the area of the rectangle. So what is it is going to do is when it is going to calculate the values in floating point because we are going to give the data length within the floating points. Okay. So what it's going to do is it is in the software based floating point multiplication. Okay. So it will store it in R0 and R1, which is special function registers, which is used to where the program will run. So it will store it in the R0 and R1 and again it returns a value in the R0. So this is how the process will be inside this. This is the assembly programming. Okay. So this is what this RC program will convert this into like this assembly programming only. Okay. So when we use the floating point unit, hardware unit means what is the uses? We will have a Vmux, and it is going to store the value in the S naught and S1, and it is going to return the value in the S naught again. So what is the advantages? It is going to be very much faster comparatively with the software. When we compare with software, it is when we doing the floating point calculation with the hardware, it is comparatively much faster. So that's why we are using this unit. So we can use or we can use or we can don't want to use. We can select this in this output. So after developing a KL code, you will select these outputs. When you go to the target, you will have a floating point order. So we can use as not used or a single precision, because we can use only single precision on Cortex M4. So the FP, the floating point operations are performed by the software FP library when we are not using. When we use a single precision, performed by the floating point unit order directly. When it comes to double precision, again it uses the floating point library. Okay. So we will have a coprocessor access control register in the system control box. So this is going to transfer data and get the data from the floating point unit. Okay. So these are the registers we have to activate in this control in this register. So for giving this full access, we have to give the load it with logic 1 and logic 1 in these 4 bits. Okay. So you can see this. We have a Cortex M4 registers and we have a separate. So what is this? The floating point unit will have a separate registers. When you compare with the ARM Cortex M, we will have a separate registers inside it. So here the main programs will be running when this floating point calculation is done. When we call the hardware, when we use this floating point hardware, it is going to send the data to the memory, and memory is going to send the data to the floating point hardware by using the vpop and vpush, and it is going to store the value in these registers only. So we have some special function registers for Cortex M and some special function registers for floating point unit. Okay, so this is how the values are get transferred. So before jumping to the next topic, we will. So before getting into the next topic, now you can convert this masterclass into an internship, guys. So it is in a 1 month internship on embedded systems. So we are already learning the STM32, which is based on ARM Cortex M4 in a register level, right? So we are learning like in a register level. So it will be very much useful for you. So you can you have to, when you have to improve yourself, you have to practice on these things. So while practicing, you need some internship like reference, like what are the ins, what are the bugs, all things you have to need some reference, right? So for that purpose, this internship is provided. And in what is the benefit of this internship is lots of topics you can refer to this internship, and lots of things going to be added in this internship, like CAN, LINs, lots of communications and tax core concepts all coming on the pipeline of courses. So so don't miss this opportunity. Our fees is 1,200. So our discount price is 599. Okay. So you can use this ESMC1 coupon code, and by using this, you have to pay only 691 only. So by paying this fees, you can register for the internship and you can get more benefits. Okay. So now we will get into what are the benefits you will get. So as I said, so we are practicing lots of codes, right? So we are practicing lots of codes in the live session, and we are developing lots of code concepts. So you have to practice yourself for making to upskill yourself, right? So when you are practicing, you will come with some errors, or you will have some doubts related to those things, or you will after executing the code, you will not get output like this. So for that purpose, you can refer to these 30 days videos. So what is the best benefit is the 30 days of masterclass live sessions will be available as a recordings in this internship. So and lots of topics also going to be added to those videos. So it will be accessible for those recordings will be accessible for 90 days. So you can use those videos as a reference for hands-on practice and developing a code. And even the concept is you are not clear with the concept means you can again rewatch it. So the concept will be get clear. Okay. So and what is the next benefit? So next benefit is we are going to do lots of hands-on practice on embedded projects, and you are going to implement what is the project I have teached you, and you are going to implement those in real time by yourself. So while developing the project, you will get lots of errors and lots of bugs. So you can, in this internship, we will provide a lots of practice on embedded projects, and you can ask the questions to clear the doubts to myself as a me. Okay. And what is the next benefit? So next benefit is you will get a 30 days of download presentations. So I am giving a presentation, right, for 30 days. So you will get this. Plus additionally, what you will get is what are the things we are using. We are using data manual, reference manual, programming manual, user manual, lots of things. So those are all the things what are we are using to develop the code, and all the things we use to learn the code concepts and communication protocols. All those files also will be included in these 30 days of downloadable presentations. So you will get the presentations as well as what are the things we are using for developing the code and the projects. And also in addition, you are going to get a codes that I am developing. So I have developing the code in live sessions, right? So those codes are going to be .c files. It will be shared you as in a format of .c file. So you can refer to those codes also. So it will be exclusively available for these internship students. So you can use you can get those codes also. So you can use those codes for reference also. Okay. And what is the next benefit? Since we will have a one-to-one live sessions. So what is this? You can interact with me for 1 hour every Saturday class. So you can ask doubts. You can clear the doubts related to the topic which I have taken from the day 0 to till the date, or even you can ask the doubts related to the embedded systems out of the topics which I have. Now I am taking STM32, right? If you have a doubts related to the other microcontrollers, or you are doing lots of other, or you are involved in other embedded projects, you have a doubt related to those projects, or you have doubt related to this other microcontroller, means you can also use those mastermind class to sessions to ask the questions related to the out of the session also. So you can ask the doubts related to the embedded systems out of this STM32 also. So you can use this mental life as these opportunities. So this is about how you are using this opportunity, how you will make use of it. So you can ask me to, you can also prefer me to do and take some new topics like some topics some core concepts you like to be learned, right? You would be want to learn those concepts. So you can say it in my Saturday class to me directly, so I can prepare on those topics, and I will be giving a presentation in this internship. So it will be very much exclusive for the internship students only. Okay, so those even out of the topic, not based on STM. If you can ask, if you want other topic more than out of this team, you can also ask me that. So you can prefer me that. So I will take this. I will get into the topic and implement those things, and I will be giving you a recorder session for you, and also I will give a code on developing those things and implementing in a real time. So these are the benefits you can get by this internship. So this is about how you are using this opportunity. Okay. So next is after registering, you will get an internship confirmation letter. So after registering, you will get a confirmation letter, and you are going to get a 2 e-certificates. What is this benefit? So you can use this certificates in the resumes. So what is the benefits? Is we are learning STM32 based on Oncodex M4, which is an industrial based controller in a register level, right? We are not using a advanced library, all libraries, or some things which will be very much easy like Arduino programming. So we are getting into a register level. So it is from 0 to ground. We are starting from ground to advanced, right? So this is a basic step. So we have to know about registers to develop the all GPU like drivers. So we are learning STM32 in register level. So this certificate will be very much useful for you. So what are the 2 certificates we are going to give? We are going to give 2 certificates. One is for participation, and another one is for course completion on this STM32 register level. Okay. So it will be very much useful to you. So the internship fees is 1,200. So don't be afraid. So you don't have to pay this full amount. You can use this ESMC 1 coupon code, so that you can get this 509 discount, and the discount fees is 691. Okay, so you can get the internship at 691 only. So this is the registration link, guys. This registration link will be available in the chat box. You can see this, or you can see this description box. In the description box, this registration link will be available. So join as an internship user and use this internship as a upskilling opportunity for you. Okay. So the Pantech e-learning is offering a 100% placement for your students who was trying to get into the embedded engineering domain or Python domain, Java's data science domain, artificial engineers, and electric vehicle engineering. So these are the domains we are focusing on. The Pantech e-learning is focusing on these domains and providing a 100% placement for these domain-based industries and companies. So guys, you can enroll for this link, and link will be provided in the description box and as well as chat box. Or you can also use this QR to scan and enroll. So you can join our team. Want to make a career as an whatever domain you needed. So what is the thing we are going to do here is we are analyzing the industries around us. So we are seeing what are the technologies they are asking from the students. What is the technology they have the industry required. So what is the technology that the industry needed. So we are analyzing those things, and as per the industrial requirements, we are training the students, and we are teaching them how to attend the interview and all the things, and we are giving them a 100% placement on based on the domain core industry. So if you take embedded, you will take a scenario of embedded engineer. So you will get a placed in the embedded domain. So the training is going to be based on the what is the as per the industry's requirements. So what are the technologies they are asking from the students. So those technologies going to be going to be get teacher going to train you for the this course for up to 3 to 6 months, and we are going to offer you, we are going to make you placed in this your dream companies. Okay. So guys, don't miss this opportunity. So you can enroll this. So enroll as soon as to get this. Lots of offers are going on. So you can enroll. Who's getting first will get the best offer. So register this and get a best offer and get placed in your dream company. Okay. Okay. So this is how the floating point unit is used, and it is the reason why we are going with the floating point unit. What is the main reason is we can do the floating point calculation and mathematical calculations in a faster way compared to the by using the software library. So this is why we are going with this floating point unit. Now we will jump into a ultrasonic sensor interfacing. So yesterday we have developed the code for generating the frequency and measuring the frequency. Okay. So we have generated the frequency and we have measured the frequency, right? So today we are going to see this ultrasonic sensor. Okay. So we will get into this. So what is this ultrasonic sensor is going to do? So it is used for measuring the distance. Okay. So what is it is going to do is we have one receiver and one transmitter. So what this transmitter is going to do is it is going to send a signal at 40 kilohertz of frequency. Then it is going to, if any object is in front of it, means it is going to be reflect to the receiver. So receiver going to receive these values. Okay. So receive the values and we are going to measure the distance. So we will have 4 pins. One is VCC, which we have to give the 5 volt plus 5 volt. Then we have a ground. Then we have a trigger pin and echo pin. So this trigger pin is for triggering this transmitter pulse. So if I give an short frequency to this trigger pulse, means it is going to send this 40 kilohertz of frequency in this transmitter. Then when it reflects and received by the receiver is going to produce a echo. Okay, now I will show you how detailed. Okay, so what is this? We will give a trigger of some kilohertz. Okay, we will say that 10 micro trigger pulse. Okay, 10 microseconds trigger pulse. Here we are going to give this. After giving this transmitter module is going to send a 840 kilohertz of sound wave generation from. This is the module which is we are using ultrasonic sensor HSC SR07. So it is going to, after this trigger is 10 microseconds of trigger pulse is given, the transmitter module will generate a 40 kilohertz of sound wave, and it will give a sonic burst of this 40 kilohertz of frequency. Then it will go and hit the object and reflect to the receiver. When the receiver is received the reflection, then the echo pin is going to be, it will be in the ideal state as a logic 0 at the initial state. Then it is going to be when this object detector and when this echo is received, then its echo pin is going to be go to the I state, which is logic 1, and it is going to travel in the logic 1 or till what is the distance of this pulse. So what is the time of this? This echo pin will be traveling in the I state as per this distance of this wave. So what we have to do is we have to measure this distance between this rising edge and the falling edge. By measuring this, we can determine the what is the distance between the object and the module. Okay. Oh shit! This page is, I think, it just came here. So guys, this is wait, I will I think this sorry guys, this page is, I think, mismatched here. So I will this is has to be explained in this floating point topic. Wait, I will stop the ultrasonic and we will get into this a single topic. So what is this? We can use only single precision in the M-Codex M microcontroller, right? So if I want to use a double precision, what it will do means it will use this registers of S1 and it will combine the both the registers and it is taken the value as an address as an D0 to D15. By this we can use this double precision. When we use the double precision library, this is the process is going to be okay. So this is what you have to want to know about floating point unit. So in upcoming class, we will do some operation with the floating point unit, or we will develop a project. We will going to develop a project, right? So we will use some floating point units in some areas. Okay. So I will come into the ultrasonic. So this is what this when this trigger is given, the burst is going to be produced, and this echo is going to be logic 1, and it is going to be stay in logic 1 till this it is going to be the distance of this frequency. So by measuring the rising edge and falling edge, we are going to determine the distance. Okay. So now what we are going to do is, so you can see this is the ultrasonic sensor we are going to use, and we have a controller here. So first you will get into the yesterday's code. We have developed. Okay. So this. So we are going to alter this yesterday's code to measure the distance as per the ultrasonic sensor. So before going to that, we will see this. What is the thing is, before getting into a module, before getting into a microcontroller or a processor or a sensor, you have to refer the datasheet. So datasheet says how it is working and how we have to make it work. Okay. So go to the datasheets. I will share this in this downloadables for exclusively for internship users. Okay. So you can see this is a ultrasonic module I am having. So this is a module provides we can measure the distance of 2 centimeter to 400 centimeters non-contact measurement function. So this ranging accuracies can reach up to 3 mm. So the module, these are the things. So use the IO, the same thing. So what is I have? So we have 4 pins and these are the workings. Okay. So timing diagram. So you can see we have to do this 10 microseconds of pulse, trigger pulse, and this will give a 8 sonic burst. Then we will get the echo. By measuring this, we will determine the distance. So we are going to measure it in the microseconds. So if I want the distance in centimeter means you can see I can use this formula. If I want it in inches means I can use this, or I want the range of the frequency means I can use this formula. So what is this 340 means? It is the sound of the speed of the sound. Okay. So this is what it is. Okay, we'll use this. We will find this. We will find the range of the frequency. We will find the centimeter, and we will also find the inches. So what is the next thing? It says the she says we suggest you to use over 60 microseconds of measurement cycle. So what it is saying is after measuring you have to give a 60 microseconds of delay. Okay, so you have to do some delay. So by you can see here you have to only need to supply a short of 10 microseconds of pulse to the trigger input, and it will start the ranging. What it is starts to send and receive the ultrasonic burst. Then the module will send out the 8 cycles of burst with the ultrasonic sound at the 40 kilohertz of frequency and raise its echo. So echo express how we will do this. So this is the thing. Okay. So first we will alter this code. Okay. Okay. So what we are going to do is we are going to get into this page. frequency measurement. Wait a second, guys. So this is a code which we have developed in previous class, right? So what we are going to do is we are going to just alter these codes. Okay. So we will alter these codes. So what is the first thing we are going to do is we have to generate a trigger pulse of 10 microsecond, right? So in STS classes we have measured the frequency and we have said how to send the 10 microseconds of pulse. So STS we have sent these 10 microseconds pulse on it. So how we will send this 10 microsecond pulse by? So 1 hertz is equal to 1 microsecond, right? Because we are using 15 here, 16 minus 1, 15. So I have to give this 10 microseconds of pulse. That means 10 hertz of frequency. So 10 minus 1, it is going to give me the 10 hertz of frequency. 10. So we have enabled the GPIO. We have enabled this channel 2. Then we have set the alternate functions. We have enabled the timer. We have set the P scale value. We have set the auto reload value. Then we have selected this output mode. Then we have selected the output compare mode. Then we have made the CCR as a channel 2 as a 0. Then we have enabled the output and we have made it the pin at the line at the ideal active low, which will be in the logic 0 at the starting stage. Then we have initialize the count as 0. Then we have enabled the count. So this generation is same as thing because SDLSF I developed based on this ultrasonic system. Okay. So we are going to do some changes in this frequency measurement. Okay. So first is we will enable this GPIO. We have same functions, channel, same thing. So we have set the alternate function. We have enabled this timer 9, right? So the same prescale value because we are sending the frequency, generating the frequency in microseconds. So we have to read the frequency in microseconds only because it will be very much easier for calculation. So next is we have to enable this input capture. Then we have to set this. We have set this time in N6. Then we have enabled this capture input. Then we have made these things. Okay. So what are the things we are going to add new to this program is what are the things? So I'm going to, we have already added this frequency, start and duration, right? So what we are going to newly add is we are going to add the, right. So we are going to declare 3 variables. So one is going to give me the range, okay. Range. So I will make it initial value 0. So what is the next I have to get is distance, okay. We will make it as a distance in centimeter and cut to 0. Then inches. Okay. 0. So now we have to declare these variables. So what is the thing we have to do? We are already configured this frequency measure as we are going to capture the both rising edge as well as falling edge. So when this distance is measured, the echo is going to be the distance is going to be the range of between the echo's rising edge and the falling edge, right? So what is the thing is first I'm going to wait till this generation has happened. This rising edge is detected and flag is till this bit is get settled. So this bit is get settled when this it detects the edge detector detects the rising edge or a falling edge. So when this rising edge is detected, it is going to get out of this loop and capture the starting. And when this again waits in this loop till this getting the falling edge, then again it comes out of this loop and it will capture this time. So then we will calculate this duration. Then we have already frequency. So what are the things we are going to add is range, right? Range. So what is the formula for the ranges? We have it in the data sheet. So you can refer to. So duration into speed of sound. So which is 340. Okay. So 340 divided by 2. So it is going to give me the range. Okay. Next is centimeter. So distance in centimeter, right? cm. So what is this centimeter is going to give us duration divided by 58. So it is going to give me the right. Where is the data sheet? So you can see by dividing it by 58, you will get the centimeter, and by 148, it is going to give it by 148. It is going to give by inches, right? So you can see inches of duration 148. So this is going to give me the inches, distance in inches. Okay. Okay. So now we will compile this. So we have no errors. Okay. So we have one. So now we have compiled this and we will upload this code into it. Before that, what's the default thing I have to do is I will you have to connect these pins, right? So VCC to 5 volt. The ground. You can see I'm connected. And we have a trigger. So where is trigger pin is? Trigger pin is PA of 1, right? So PA of 1, I will connect this in PA of 1, and I will connect this echo pin in this PA of 2. Okay. So now we have connected this thing and I will upload this code. I will do this and I will upload this code. So now we will see the debug. So we have already added these values in the watch. So now I will add these new values to the watch. One. So we will take these. Okay. So what is the thing I'm going to do is I will now we will copy this. So you can see here. Now I will. So you can see the distance between the module and the monitors before this module. The distance between the monitor and this module is now it is 8 centimeter and 3 inches. Now I will go back. Okay. So you can see the inches and centimeters now get increased, right? So it should be now. So we will this like this. Okay. So now it is in a range of 3 inches and 8 centimeters. So we will give these values. So you can see our distances vary. So now it is to this table to this module the distance is 14 centimeter. So we will get this values. Okay. So you can see our distance is getting increased. Okay. So this is how we will configure these ultrasonic sensor. Okay. So guys, today's class is over. Thank you for the session. We will meet on next session. Thank you guys.